Hello and welcome to our presentation on Design for Improved Ergonomics for Shot Blast Operation, supporting the Timken Company. The goal of this project was to continue the work of the Phase 1 team in correcting the ergonomic concerns identified by the Timken Company in the shot blast area. The Phase 2 team has worked on taking the project from design to implementation on the manufacturing floor over the 2020-2021 academic year. The proposed solution has parts being removed from the bins by an electromagnet and conveyed to the operator at an ergonomic height where they can easily load the parts into the machine.
The requirements and deliverables will be the reduction or elimination of ergonomic concerns based off of industry standards. There will be a complete design package and a full-scale proof of concept model.
There are four performance specifications for this project. The first one is that parts will be brought to a height between 39 to 48 inches to be most ergonomic per human tech guidelines. The second one is that a robotic arm will be used along with an electromagnet to pick up parts. The third one is that the parts will go through a demagnetizer to neutralize the magnetic field created by the electromagnet. And the last one is that the proposed solution must be simple enough to be used by any operator.
The following is the design and review for Tim Ergo 2's project. The carts will be located in the cell via a notch cut into the floor. From there, the robot combined with the magnet, port sensors, and PLC will find the parts in the basket and remove them. The parts are then placed onto a series of belt tables which will deliver them to the operator. The parts will also have to go through an escapement and demagnetizer one at a time with the help of the photo ion sensors throughout the table layout. The sensors work in conjunction with the escapement to ensure the parts do not overflow into the demagnetizer.
The presentation table will bring parts to within 15 inches of the operator at a height of 39 inches, eliminating the need for the operator to rotate more than 90 degrees. The robot is enclosed in the work cell by means of locking doors and the machine guarding enclosure, and the operator will have access to full process stops located close to the presentation table in case of an emergency. The electropermanent magnetic chuck reduces the possibility of parts being dropped in the event of power loss.
The part picking process will utilize the FANUC robotic arm, an electromagnet, load cells, and a PLC in order to move parts from the heat treatment basket onto the drop table, so that parts may be presented to the operators at an ergonomic height. The mechanical components of the project, such as conveyors, machine guarding, and cart positioning constraints, have been built and implemented. The FANUC robot program has been established, but further research and development is required for it to be fully automated, along with the PLC code, which has been tested and awaits integration via the electrical controls. The electrical control system's design has been completed, but the physical build of it is still in progress by Timken and contractors. This leads to the inability to test the integrated electrical and mechanical components of the system.